So today I will explain a bit more in detail what is a full node and how to bootstrap a full node. The main goal of a full node being to support the blockchain, right? I mean, the blockchain is composed of many full nodes, all of the nodes storing the chain and coordinating all together in order to broadcast the transactions from one to the other, from the end to the miner and so on. So bootstrapping full node basically is should be as quick as possible, so that the entry barrier for all of you is the best possible. Basically, bootstrapping a full node is going from starting a Docker container with the latest version, or I mean, we have different versions of shipping the full nodes. The most convenient I find, but I'm completely based regarding that, is the container version. So we can simply run a command like that, docker run, open some ports and run the latest version, which is 3.1.4. And then it starts connecting to Bootstrap nodes and then start fetching the nodes until, well, there's endpoints on the API port called info self-click, and there it's a JSON data which returns a sync object, and we are looking for the value true on this. So bootstrapping a full node is starting the process until this call returns true, meaning that the full node is now in sync and can participate to the blockchain. So there's a lot of buzzword about DevX these days, right? Developer experience. I'm more an ops. I'm in charge of the infrastructure, so I like to talk about OpsX, which is exactly the same. The idea is to provide the best operational experience to the one who wants to run a full node. And the best experience we can do is giving you a one-liner to run the nodes, and that the Bootstrap nodes process is going as fast as possible, as I just mentioned. Running a Docker run command is easy, it's convenient, but you would prefer maybe the running in Docker Compose, so you have a descriptive file doing that. We provide all that in the GitHub repo. There's a project called Alephium Stack, which is mostly maintained by Hongqiao, which provide everything, including monitoring of the full node with the Grafana dashboard and all that. So that's really cool. Let's do a demo. So I run the nodes on AWS. I just started the nodes. I have a README file for copying, pasting my commands. That's the command I pasted before. The only difference I'm running here is I'm inserting a bit different. Zut. I'm using a slightly modified version of the user.conf because I'm listening on a different port than the default port 9973, just for a reason of listening on port bigger than 10,000, but that's nothing really important here. So I just take this and I start my full nodes, some stuff going on. So it's sort of initializing the codes, loading stuff. It will then try to contact the Bootstrap nodes. I'll go a little bit into details. The Bootstrap node will then send some peers. Here are peer information. You see the IP of the peers. Perfect. And then it waits some time until it discovered enough peers to get a sort of quorum before starting fetching the blocks. These nodes here will start from scratch. So the first block you will see, we will be able to see that on the Explorer, are really block at ICE 1, right? And that's really nice to see. So it's connected to some, and now just stopping the process, going back to the logs a little bit higher. Quite a lot of block already synced. I spoke too much. We are close. So that's the hash of a block at height 1, right? So I can then go into the Explorer, should have here, paste the block, and I see the block height 1. That's one of the first blocks that got generated on the network, the November 8th, 2021. And so on and so on. So now this process is connected to some nodes and start fetching all the blocks one after the other. This process takes a bit of time, and that's not a very great operational experience. I went to the demo. So what I just showed is actually a complete journey, right? So the full nodes connect to these Bootstrap nodes. There's the link here. That's the code where the full nodes, so the Bootstrap nodes are defined. There are 6 as of today, called Bootstrap 0 up to 5. This one points to IP, and then your node, when you start connecting to these IPs. After you connect to the Bootstrap nodes, you're looking for peers, what I showed in the logs. You connect to the peers, and then you start loading the block until it's synced, and then you can participate in the chain, bootstrapping, broadcasting transactions, and so on. This takes nowadays around 20 hours, maybe a bit less than 20 hours if you have a decent servers with especially enough IOPS. And before run upgrade, so they did quite a lot of optimization in the full nodes. Before the run upgrade, it was taking more than 2 days to bootstrap a full node, which is not a very good experience. You want to run something locally or try something, you have to synchronize your node, you have to wait 2 days. So it's not the best experience we want to provide to the community. So we started thinking about bootstrapping from a snapshot. And from a snapshot, then it's basically the same kind of command, just a slightly modified Docker image, which contains the code of the full node plus some wrapper around, which will do some magic, and then checking if the node is actually in sync. It's exactly the same command than before. And I'll do a demo. So I'm on that node. Oh, sorry, yeah. Yep. So I have my cheat sheet, and that's the second command. I will just run the same command almost than before, just storing the data on the physical server and not inside the container. Running this, the beginning is exactly the same, loading the config and so on. But there's a bit of magic. Just removing what I had before, otherwise it's cheating. So I start, and then the beginning is a bit different. It starts downloading something from the internet. So it's basically download the snapshot or the latest snapshot from the internet, and it will take a bit of time. And my goal is for this presentation to have a full node in sync at the end of the presentation. Not sure if the bandwidth is good enough. I see here the time left, which might be a bit too much, but I'll go into details to see what is happening under the hood. So what we're doing is exactly the same, except that we are wrapping our full node with a bit of script, and this script is first downloading a snapshot from a website, the website being archive.alephium.org. And then once the archive is downloaded and decompressed or untarred, then the process is exactly the same. It starts a full node, which look at Bootstrap, look at peer, connect to peers, and then start downloading or getting in sync. But since we have the snapshots, we're not starting from day one. We start from the time of the latest snapshot, which then helps, and you only sync for the delta and not everything. And then you can participate in the blockchain, and this should take around 30 minutes. If I'm lucky, it can even last less than that, but we'll see that afterwards. So the demo is launching the full node. I anticipate a bit to give me more time still for the node to sync, but that's how it is. Good. So now we went from 20 hours to less than 30 minutes. Sounds too nice to be true. There's a trap. So where's the trap? That's the big question. So the trap, or the how we are doing this, is through this archive.alephium.org website, which is where the magic resides. So I'll take my browser again, and that's the website, absolutely designed by, absolutely designed by me. So as a reminder, I'm an ops, right? I'm not a UI guy, I'm not a UX guy. So I really did my best on the UI here. Basically, you go there, you have two folders, one for the mainnet, one for the testnet. If you go to mainnet, you have the full nodes, the full node data. We're also taking a snapshot of the Explorer database. And here, so we see we have 4 snapshots. We're taking a snapshot once per week, and then you can download this file, or we point to a file called latest, and the latest is basically a redirection to the latest one that have been uploaded into the archive website. So nothing really new here, just a sort of file repository where we store the snapshots. But as you can see, the files are quite big these days, or they tend to increase over time, and that's where the difficulty comes from. So we are taking a weekly snapshot of the blockchain, and snapshot is basically, so I'm just starring, so when the full node is in sync, I'm stopping the full nodes. There's a folder where the blockchain is stored. I'm just taking a tar of the folder and I'm uploading it to the website. There's no compression. The data is stored on the blockchain in a database called RocksDB, and RocksDB is already doing some magic in compression and so on. So adding one extra layer of compression on the tarball doesn't help much, except consuming a lot of CPU, which was not really needed at that time. So to take the full snapshot, or the snapshot, it's something like that. The process is the following. I'm starting a VM, well, on AWS, because that's my favorite cloud, but could be anywhere else. I'm downloading the latest version of the snapshot, so the one from like a week ago. I'm letting the full node syncing the delta, and then I'm checking that the full node is in sync. When it's the case, shutting down the full nodes, taking a snapshot, uploading the snapshot to the archive website, validating the snapshot so that I know that the one published is working, and then publishing a snapshot, so making it available for everybody. For the workflow, so how I implement that, I'm a big fan of a tool called N8N. Not sure if you know the tool. For the story, I wanted to do some IoT automation with my kids, and I wanted something visual. So I started searching for this tool. I found this N8N, and I felt in love with the tool, so I kept it. And I'm a big fan of Slack Ops, so the workflow then reports some message on Slack if it's success, if there's error, and so on. But I'm notified. I don't have to look at logs all the time. The workflow is, look, in N8N tool looks exactly like that. So here, I don't want to show you to show the detail on purpose, right? Because then I feel smart and cryptic. But if I go a little bit into details, what I'm doing is I'm cloning a Git repo where I have all the code for snapshotting the nodes. And then I launching the instance on AWS using Terraform. Then I wait for the node to be in sync. So here it's basically looping a certain amount of time up to 2 hours. After 2 hours, if my node is not in sync, it means I have a problem somewhere. I get notified and I can manually check what's the problem. I'm then taking the snapshot and uploading the snapshot and publishing the snapshot, finding the snapshot, and then I'm sending nice message like that on Slack, like mainnet full snapshot has been uploaded, and even some details about the size, so 112 gigabytes of data right now. So this is running. I'm doing that for mainnet, testnet, and so on. I also have workflows to validate on demand the snapshots if I have a doubt, or I'm testing from time to time now with the Roan upgrades. The Roan I mean, it was quite a big upgrade, so I'm testing this a bit more often than once a week, just to be sure that the setup is working fine. So the snapshot size, of course, is increasing over time. It's a blockchain. We keep all the history, so it will keep increasing. Before Roan upgrades, we were about 700 megabytes per week of increase. Now, after Roan, we are something between 3 to 4 gigabytes per week. I'm still missing data points to have a proper curve, but we can really see that starting from 0 after Alephium, so there's 0 after Jesus Christ, so there's also a 0 after Alephium. And to Roan was quite a steady increase. And now with the Roan, since we are producing 4 times more block, we also expect the blockchain to increase from the same ratio pretty much. As I said, The full node, the latest full node from Friday was 112 gigabytes, which is not that much, but still you'll see that this is actually a real problem. So in order to keep the snapshot small, because it kept increasing, one of the features that have been added into the chain is pruning the snapshots, and this helped a lot. Pruning a snapshot means basically running a process that will retain the 200 latest, most recent blocks and some of the metadata of the history, but then clean everything that is not needed out of this. And so we have a workflow for running a prune snapshot, which looks exactly the same than before, except that once the node is in sync, we run this pruning process, and then we take the snapshot of the prune version, and we do the same magic afterwards. This now is also available in the testnet. I was discussing yesterday with some of you guys, and you say you wanted to have it on the testnet, so I worked on that yesterday evening as well. So now we have the prune version on the testnet as well. So if I go back to here, we can see those. That's the full snapshot. Thank you. Sorry. So you have the full snapshot here, and if I go to the prune version of the snapshot, you have the same structures, just a slightly different naming convention, and you can see that the size is something more affordable. And for the testnet, it's exactly the same. Testnet, the full nodes, the size of the testnet chain, and the prune version. There's one yesterday evening. I can't cheat on the time, so you can see when I worked. That's the prune snapshots, smaller data, lighter. We try to keep it as close as small as possible. Now, the biggest problem is basically this, what we call data inertia, right? If you do a little bit of math, downloading 112 gigabytes at, say, 1 gigabit line speed takes 15 minutes. You can't compress this. So if you want to have a full node starting in less than that, you need to have more bandwidth to download your file, just because of the data inertia that you're doing, right? And actually, moving this amount of data through the internet a lot of time has been proved to not be that easy, and that's the second part of my presentation. So the first try is I started storing this snapshot on a bare metal server. I know OVH, that's a French hosting provider. They provide bare metal servers, so you pay for the server, and you have a certain amount of bandwidth which is included. So fixed price, flat price, nothing hidden, very cool. Pros is that you have really this fixed price. You know how much you pay in advance. The cons is the bandwidth might be a little bit limited. The server we had was around 100 euro per month, and the bandwidth was capped at 1 gigabit. Started uploading the files over there. Then we had the Flux project. We provided image to start full node on Flux, and everything went well until, not sure, you don't see that much. You see that better? So basically, you see the bandwidth increase up to the hard cap. Here, that's really the 1 gigabit limit. So my instance was sending data to many different peers, and then I started having message from a pool admin saying, we're trying to sync a node, and we download the snapshot at 100 kilobytes per second. We're like, oh shit. So then moving this to a different server, so since it's a bare metal server, I had to do some data migration from one server to the other. I'm capped with the bandwidth, so it didn't help. Then I started thinking, well, I have my instance on AWS. AWS has a very nice way of storing data, which is called S3, right? S3 is really nice. You have an HTTPS endpoint, you store any kind of data over there, and then you start serving data. So second try, let's upload the data into S3, starting a new server, syncing, taking the snapshots, pushing the snapshots to S3. S3, the pros of S3, it's convenient, everybody knows, it's scalable, blah, 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 all the marketing bullshit. I don't have, I'm not here, I'm not an Amazon salesperson. The cons of S3, I knew that there's some egress fees out of S3, but I was like, yeah, that's okay. I think everybody is using S3, so why not me? So I started S3 on one single day, and then that's the result. That's the cost of AWS S3. It cost me for one single day $340 for egress only. So the amount of data paid just for sending the data to the other nodes bootstrapping costs 340. So I stopped. I didn't want to have troubles with Chang nor mode, you know. I was like, shit, I need to find something else. That was an interesting fail. Just for you, I'm not sure if you know this one, so the one using a little bit Amazon. There's a nice illustration showing what you pay. Basically, the blue line are the free, and it's interesting to see that most of the free traffic is the one going into AWS, and all the others going out are the one you pay for. I mean, it's a business model on its own, right? Send me your data, and you will pay to get it back. So, AWS S3 was absolutely not an option, so I had to find something else. So I did a third try. I was like, okay, S3 is still very convenient. So what about finding S3 compatible alternatives? So I started looking around. The pros again is S3. Yes, that's cool. Should be cheaper. There's probably some egress fees, but less egress fees. I had a survey on OVH. OVH provides S3 compatible storage as well. And here the same. I ran it for one day again, 211 euros. So it's a bit less than AWS. I was happy with that, but still, I will, if I kept that there, I will still have issues with more than Cheng, right? So not an option. So I did much more trials. I basically Googled for S3 compatible storage provider. I tried all of them. I read most of their terms and conditions to find, you know, the little line saying there's some egress fees here that applies, but not that much, you know, but still. And so nothing really worked until I found my lifesaver. I was really too nice to be true. Again, I really searched for the trap, but Cloudflare provides a service called Cloudflare R2. And Cloudflare R2 is a S3 compatible thingy, and they really market it as zero egress fees. Yeah, I was happy with that. Migrate everything to R2. Since the endpoint was compatible, I didn't have to change a lot in the process. And actually, it's really zero egress fees. So now, going down from 340 or 211 something per day, on R3, storing all the snapshot cost $11 a month. So something that we can really sustain on the long run. It works well. There's some limitation, of course. The download is throttled. You can only download around 300 to 400 megabits, but everybody has this bandwidth. So it's not as fast as we could have for the thing, but if 100 nodes download the snapshot at the same time, everybody gets their shares of bandwidth. So it's really what saved my life on this snapshot story. I tried some other alternatives, torrent, for instance. The problem of torrent is that nodes should download at the same time to share bandwidth, but on the other hand, torrents work well with UPnP. If you run on servers, you don't have opening ports, automatically opening ports, so you have a really shitty bandwidth. I tried IPFS, all of you doing NFTs, store stuff on IPFS. IPFS works apparently well to store small files. For big files, it's not really convenient. Even the hosted for you version, like Web3 storage, for instance, they also have egress fees, so it's a no-go for me. And there's probably some more stuff I can test. Yesterday, I learned about Arweave project for storing data. So that's something I didn't start yet. But at the time of writing this presentation, Cloudflare R2 is good enough for me. And I will probably stick for quite some time over there. That's it. I want to go back to my nodes and see if it's in sync. Yeah. That's my comments. Well, not synced yet, but if I get the logs, Yeah, that's what I want to check. Lungs. So that's, I'm at height 1,200,000, so I'm not that far away, but I'm not exactly there yet. I'm pasting it here. Yeah, I'm June 22. I'm missing a bit of time to complete the sync. That's what, yeah. I'm really close from being in sync, just missing maybe 3 more minutes, but my node is really close to be sync, and it's running since 17 minutes. So probably in 20 minutes, I would have done, I'll speak a little bit too fast to have my demo completing, but that's pretty much it. Thanks for your attention.